percent is defined as a fraction with 100 as the denominator. To find a percent of a value means to multiply the value by that fraction. So if you're going to find 22% of 80, you're going to multiply 80 by 22 over 100. And when you do so, you get 17.6. Okay? If you're like me, you don't necessarily always like dealing with fractions. We can avoid using a fraction by just doing 22 divided by 100. When we do 22 divided by 100, we get 0.22. Okay, a shortcut to that would be if you have 22, we know the decimal point's the last part. You just move it over 1, 2 places. So that would be 22% as a decimal, which is 0.22, or just divide it by 100. And you still get the same answer. You get 17.6. Divide the percent by 100, or just move the decimal point over 2 places. And that gives you the percent as a decimal. Okay. If you want to find percent increase, you need to add the percent back to the original value. If you want to find percent decrease, you need to subtract the percent from the original value. This can be done in 2 steps or 1 step. For our purposes, it will be important to understand the 1-step method. So take, for example, you need to pay 15% tax on a car that costs $12,000. You want to find the total cost after tax. Well, this 2-step method would be, and some of you might be thinking this, well, just take 15% of 1,200 and add it back in. Okay, well, just like the last one, 15 divided by 100 gives you 0.15. Or again, just move that decimal point over 2 places and you get 0.15. Times 1,200. Oops, got a 0. Go ahead and plug that in your calculator. When you do so, it gives, you should have gotten 1,800. Okay? That's how much the tax is on a $12,000 car. 1,800. Then what you would do is just do 12,000 plus 1,800, and that will give you the total on your car. So when you calculate that, you should get 13,800. So that's how much you would pay for your $12,000 car if there was a 15% tax. Right? That would be 2 steps. There's a much easier method by just using 1 step. Okay? You take the 12,000, the price of your car, and all you have to do is take that percent as a decimal and add it to 1. And multiply that together. Okay? You just take the original amount, which was 12,000, and multiply it by 1 plus the percent as a decimal, so 0.15. Okay? You can plug that in your calculator all in 1 step, or you can break it down a little bit. You can do 12,000. 1 plus 0.15 is 1.15. And when you plug that in your calculator, you should get the same thing. The reason why this works is, think of it as you took 15% of the original amount and then added that back into 100% of the amount, the original amount. Well, you're just doing that in 1 step here. Your just percents are just written as a decimal. 100% written as a decimal is 1. 15% written as a decimal is 0.15. If we add those together, multiplied by the original value, it will give you the price after tax. Okay? These next ones, go ahead and pause the video. Try these next three on your own. Take about 3 minutes. Try them on your own, and then we will go over them together. So go ahead, pause the video, and I'm going to start going over them. Okay. Again, for these practice problems, we're going to use the one-step method to calculate the total. So for A, it says you go out to dinner at a fancy restaurant and the bill is $68. You want to leave an 18% tip for the waiter. How much do you pay in total? Well, again, you take your initial amount, 1 plus your percent as a decimal, divide 18 by 100, or just move that decimal point over 2 places. Plug that in your calculator, and you should have gotten around $80.24. Same thing for B. It says Megan feels that tofu for you are on sale for 30% off. The mixed food bowl normally costs $8.50. How much does it cost with the sale? This is a little different because in the past you added a tip or you added on tax. For B, it's a little different because you're taking off a percent. So if you're taking off a percent, you're going to be not adding it to 1, but subtracting it. You take the original amount, and this time, because we're taking away 30%, you're going to subtract. And again, 30% as a decimal is 0.30. When you plug that into your calculator, you should get $5.95. And then for C, it says your current balance for your Visa card is $522. Visa charges you a percentage of the remaining balance each year in exchange for allowing you to borrow money from them, called the annual percentage rate, your APR. Your APR is 12%. If you don't make any payments this year, assuming there are no late charges, how much will you owe at the end of the year? Okay, so again, same thing. You take the starting amount, 522. They're adding on that percent. They're adding on the 12% from your total. So it would be 1 plus 0.12. And when you plug that in your calculator, you should get $584.64. So for the next one, it says if you continue to not make any payments, how much will you owe at the end of 2 years? So this amount right here was the amount after 1 year. So that would be your new initial amount. So you would say 584.64 times 1 plus 0.12. Plug that into your calculator, and you would get $654 and around 80 cents. Okay. This can be kind of a pain in the butt. What do they want to know how much you would owe after 7 years? You really want to calculate year 1, and then year 2, and then year 3, and then year 4, and up to 7. That would be a lot of unnecessary work. There are some shortcuts we can use using these equations. Increasing exponential models. Again, that's when you're adding tax, adding interest, adding a check, things like that. You would use this equation. A of t represents the total amount after a given period of time. That's what you're trying to find. Give it as 1. A represents the initial value. P represents the percent. Again, you always write it as a decimal. And T represents time in both equations. subtract. Okay? So let's take a look at some more examples using these equations. In example 1, it says write an equation that gives the savings S in an account if $250 was invested at an interest rate of 3% per year. Then determine the total amount in the account after 12 years. Round to the nearest cent. The tricky part of this is realizing if you're increasing or decreasing. So think if there's an interest rate, if they're adding interest into your account, okay, it's increase. So we're going to use this equation. Okay, so we need to know our initial amount. Our percent as a decimal, and time. Okay, and again we're using this equation. Right here. Adding interest, so we're going to add our percent as a decimal. Okay, well our initial amount, we start out with $250. Time is 12, and our percent as a decimal would be 3% as a decimal. This is where 3 gets tricky, these single numbers. If you divide 3 by 100, you get 0.03. Or if you use that method where you move the decimal point over 2 times, there's that gap there. You have to remember to fill it in with a 3. Okay. Well, first we just want the equation. So when we write our equation, it's going to be S of t, because that's a nice big variable they gave us. What our outside variable is going to be. T is always dealing with time, so that's what's going to be inside your parentheses. Our initial amount, which is 250, times 1 plus your percent as a decimal, which is 0.03. And then we just want the equation, so we're going to leave our exponent as t. Okay? First step. Then we want to evaluate it after 12 years, so you're just going to take 12, the time, and plug it into t. We get 250 times 1 plus 0.03, so it's 4.03 to the 12. Go ahead, just plug that into your calculator, and you get $356.44. Give me a minute, get that down. Scroll up just in case you need me to. Okay, take a look at example 2. So if the population of a town is decreasing by 4% each year and started with 12,500 residents, what would be the projected population in 10 years? I'll again show up the setup of the model, round to the nearest whole number. Okay? Again, this is going to trigger you whether you're adding your percent as a decimal or subtracting. If it's saying any talking about decrease or taking away, depreciating, things like that, you're going to subtract your percent as a decimal. So it's going to look something like this. This form. And again, I like to think this is your initial amount all the time. You just fill in these equations the same way. You just have to decide, am I adding the percent as a decimal or subtracting the percent as a decimal? You take your initial amount. So the initial amount of people, 12,500. 1 minus your percent as a decimal. 4% as a decimal, if you divide it by 100, 0.04. And then your exponent's always time. The time they gave you was 10 years. If you need to simplify what's inside your parentheses, if you can plug that in your calculator in one step, go for it. You get 0.96, and then plug that in your calculator. When you do so, you get 8,310. That's the population, that's not enough money. You just get 8,310.41. When you round the nearest person, though, the whole number, we can't have 0.4 of a person. This is your final answer. You need it. And as always, the initial amount goes first. Inside your parentheses, it's 1 plus or 1 minus, depending on your situation, your scenario, your percent as a decimal, and then time is always your exponent. We look at example 3. This is given the exponential model y equals 200 times 0.80 to the x. Determine whether the model represents exponential growth or decay. State the percent increase and decrease as well as the initial value. Okay, well this inside part is going to tell you whether or not it's growth or decay. If it's bigger than 1, remember it's going to be growth. If it's smaller than 1, it's going to be decay. It's not necessarily always be written as a fraction. So because what's inside our parentheses is smaller than 1, 0.80 is smaller than 1, then we know it's decay. If it was bigger than 1, then it would have been growth. Okay? The percent increase or decrease. If it's decay, you know it's a percent decrease every time. If it's growth, then it's percent increase every time. Okay? So what you're trying to figure out is, if you start from 1, how much did you go down from? So if we started out with 1 and we went down to 0.08, subtract the 2. We do 1 minus 0.08, that gives us 0.20. Alright, but remember it's a percent, so we're kind of reversing what we did to go from 0.20. Just move that decimal point over again, and that will give it to you as a percent. Or multiply it by 100. So our percent decrease is 20%. You can also think of it as, well, 0.8 as a percent is 80%. How much more do we need to get to 100? 20. You can think of it like that, too. Okay. And then the initial value, it's just this number out in front. So our initial value is 200. I'll make a note there, too. One more example. Look at example 4. It says from 1991 to 1995, the number of computers seized for 100 people worldwide could be modeled by this equation. 25.2 times 1.15 to the 2. Where t is the number of years since 1991. Determine the initial amount and the percent increase or decrease. Again, the initial amount is what is in front. So our initial amount is 25.2. And then the percent increase or decrease. We'll look inside your parentheses. yourself is that bigger than 1 or smaller than 1? Bigger than 1. So we know it's a percent increase. And how much did we increase by? And that would be 15%. Couple ways to think about that. Again, just subtract it from 1, and you get 0.15. 0.15 as a percent is 15%. You can also convert what's inside. So 1.15 as a percent is 115%. Well, how much did you go over 100%? By 15. So your percent increase would be 15%. How much did you go up by? From 100, you went up 15. And then we're going to use this model to predict the number of computers per 100 people in the year 2000. So again, we'll use this equation times 1.15. Here's the thing, we have to figure out our exponent, which is always times. This equation is representing years since 1991. So how many years did we start in 1991? And we're going to 2000. 9 years have passed. So 9 is going to be our exponent. Go ahead, plug that in your calculator, and you should get 83.